fixed hour method, and sorry, I made a mistake. It's a stadia tachometry, and you have got the tangential tachometry. The stadia tachometry, you have got fixed hour and movable hour. Then the movable hour, you got horizontal and then the vertical. So these are some of this thing. But nowadays the tachometer refers to a theodolite fitted with the stadia hour. What is that? So in the field of view, if you look at it, you will find that these are the horizontal hour and the vertical hour or the cross hour. So you will find two more hours here. These are called stadia hours. These are called stadia hours. Okay. The stadia hour, they are fixed actually. So in the field of view, when you look through the telescope, you will find that when you are adjusting the telescope for that, you will find the horizontal hour and the stadia hour. We make use of these stadia hour in finding out what is the distance between the 2 points rather. Okay, so this is it okay for you? No, okay, fine. I have to update it. No, it's only the principle of similar triangle. Suppose I have a point this way. I have now holding a. So suppose I have point A, B, C. And I want to find out what is the distance OA, OB, and OC. Okay. Depending upon that, we say that we have got C1, C2, P1, P2, A1, A2. I can say that, and this angle is beta. So OA, I just put this as OA. OA by A1, A2 equal to OB by B1, B2 equal to OC by C1, C2. Okay. So it's nothing but your tan of the cot beta by 2, this angle. So beta by 2, we said that angle is 0 degree and 34 minutes and 22 seconds. If you find out this some constant, if we are using the principle of what we call a similar triangle and then make use of it. Similarly, what is that you should understand is suppose I have objective. This is my objective. This is my objective. Okay. Now a ray from far off just passes through the optical center of it. Like this. And then it incident, and then you will be having the field of view like this. So this is my objective. Okay, this is my, I'm holding a top at a far off point like this, and this is the geometrical center of the telescope, and the distance between the objective and the center of telescope is like, so this is my image, and this is your field point. So the horizontal distance is given by this. Horizontal distance is given by this point. Okay. So from that to the center of the instrument is the horizontal distance. And I make use of the principle of optics. So what is that? U and V. So this is the intercept, the staff intercept. The ordinary leveling staff can be used. This is the staff intercept, and this is your the distance between the stadia here. I put it as I. Okay, and this is your V. The principle of optics, you know that. So U by V is equal to S by I. Okay, S by I. And the principle of optics is that 1 by F focal length is equal to 1 by U plus 1 by V. Okay. Suppose I multiply it completely by UF. What is that I get? So completely by UF. Can I rub this? When I multiply by UF, what I get? U is equal to F plus U by V. Oh, sorry. Yeah. Into F. Okay. And U by V is equal to S by U by V is equal to S by I. So I substitute it. U is equal to F by S by I into F. But what is D? D is equal to U plus D. When you substitute it, horizontal distance D is equal to S by F by I into S plus F plus D. So that F by I put it as some K, and F plus D as some as C. So D is equal to Ks plus, okay, Ks plus C. The beta is very, very small. This angle beta is very, very small. So your this thing, your F by I become more equal to 100. So 100 is an easy number to remember. So K is called a multiplying constant. K is called a multiplying constant. and F plus D, which is equal to C. C is called the additive constant. Normally K value will be 100 and the C value will be 0.3. Okay, the K value is 100 and C value is 0.3. Suppose I am holding a star at a far off distance. My stadia intercept, can I give you a problem? My stadia intercept is 1.035 and 0.065. Okay, 1.035 and 0.065. Okay, so what is the horizontal distance between the instrument point and the stop point given K equal to 100 and C is equal to 0.3? How much is that? Can you calculate? You get it? Do you get this value? Boys, am I audible? Are you working on this?
Yes.
You are able to understand the problem? Hello? No, nothing there.
Sir,
No.
can you repeat the question?
See, I'm holding a star at a far off distance. The star readings, the stadia intercept is 1.035. Sorry, I made a mistake. Okay, 0.065. Okay, 1.035 and 0.065. What will be the middle room reading? What will be the middle reading? So you will have the top reading 1.035, 0.550, 0.065. So between this and this, the difference is 1.035, 0.065, 0.970. So horizontal distance D is equal to Ks plus C. This is equal to S. So 0.970 multiplied by 100 is 97 meter. So C is 0.3 meter plus 0.3. Answer is D is equal to 97.3. You get the point? Huh? Suppose the height of instrument is 100. Height of instrument is 1.5 meter, and RL of the instrument point is 100. Height of instrument is 1.5 meter. Okay, RL of the instrument point is 100. What is the RL of the stop point? RL of RL of instrument point is 100. Height of collimation is 1.5 meter. RL of stop point. What is RL of stop point? 101.5 minus 0.550. How much is that? 100 point. What is the RL of the point, boys? This is 101.5. Then axial hair reading is 0.550.
Yes, sir. 100.95.
100.950. Do you understand that? 100.950. So this is the vertical angle is 0. All these things. You are reading the stuff. You can, when you are using a level instrument also, you can find out what is horizontal distance between the instrument point and the stop point. Hereinafter, the theodolite level will be called as a tachyometer. Tachyometer is the one which is fitted with the stadia hair. Okay, it's a stadia hair. Now what happened? Our instrument is inclined. Instrument is inclined. And I'm holding a cup vertically. Get that? I'm holding the cup so these are my top hair reading, axial hair reading, bottom hair reading. Okay. So this is the center of the instrument. This is your this thing. So if you look at it, this is your length L, the slant length L. But I am interested in finding out what is the horizontal distance. So angle your with respect to the horizontal, your this thing is theta. Your angle of elevation is theta. Now if you look at these angles, this is something beta by 2 and this is beta by 2. Small difference in angle. Now what I do for a small purpose, I just see that this is construct a normal. So this is a problem with this. So for my sake, what I do is I just construct it. So this is the perpendicular, okay? Okay, this angle is your theta, right? Right? This is 90 degree and this is 90 degree. So what is this angle? This is beta by 2, 90. So this is be 90 plus beta by 2. Okay, and your this angle, this is the total staff intercept is yes. You get this nomenclature rather. You can get a nomenclature. Okay. So if we consider this triangle and this angle is theta, this angle is theta, and this is s by 2. Okay, this is s by 2. Up from this point to this point is s by 2, and this point to this point is s by 2. Yeah, what is s? What is s? You have been hearing a Ramayana. S is the, what is S? S is the staff intercept, boys. S is the staff intercept. You are holding a staff at a far up place, and this is your theodolite point, and a far your staff, and then finding out what is the staff intercept. The staff is held vertically. Staff is not perpendicular or normal to the line of sight. No way it is normal to the line of sight. It is held vertically. At a point you are holding the staff. Do you understand this? You understand this or not? When you consider this triangle, this is 90 degree, this is beta by 2, so this is B 90 plus beta by 2. Similarly, here it is 90 minus beta by 2. So this angle is theta because the angle of elevation is theta. So what I do is I consider that beta is very small. I conveniently eliminate and I consider this as your rectangle triangle, and this is what is this is yes. The component of this is s by 2 cos theta. The total is so s by s cos theta, because you have got s by 2 cos theta plus s by 2 cos theta. So it is equal to s cos theta is this. Agree? S cos theta is this. What is L? What is L? L is equal to Ks plus C. Here S is equal to S cos theta. So your this thing is L is equal to Ks cos theta plus C. Because the S component, this part is S cos theta. So K into that part S cos theta plus C. What is D? D is L cos theta. D is L cos theta. So what is so D is L cos theta. So D is equal to K into S cos square theta plus C. So the line of sight is inclined. The line of sight is inclined. Okay. Line of sight is inclined. You have got a formula. Where is theta is angle of elevation or depression. Angle of elevation or depression. Do you get the point? Right? So this is the book work, right? Now I just wanted to find out what is H. What is H? This is H. What is H? How will you find out H? What is this green line? What is the green line? What is the green line? Dotted line. This dotted line. What is that line? Oh, yappa. What is this line? What is this line? And what is this line? The lines have got three different nomenclature. What are those three? What is this line? The top line, dotted line. Yeah. Do you see the figure? Hello?
Yes, sir.
Yes, sir.
Ah, you tell me now.
Horizontal line, sir.
What is the top line?
Horizontal line.
Horizontal line. It's called a horizontal line. What is this line? The curved line.
Level line.
Level line. It's called a level line. What is this line?
Line of
Line of collimation. You understand that? So, why that in between line I have drawn? Because the line of sight, because of refraction, it go up. The total correction, curvature correction, 1/7 of it is your refraction correction. So 6 by 7 of it. So you remember the value 0.06728 d square, no, is equal to your h. Taught you that. Similarly, I got a horizontal line. Over a horizontal line, the center of your staff intercept is your h. How will you find out h? What is h? Sir, சொல்லுங்க sir. Hello? What is h, boys?
Sir, S by 2 tan beta by 2.
Tan theta, that's all. H is equal to d tan theta. Ila? H is equal to d tan theta. Then this is theta. H is equal to d times tan theta. This theta angle, no? So once you know, sir, சொல்லுங்க sir. சரி சொல்லுங்க. தெரியல, நான் என்ன அவர்கிட்ட ஃபோன் வரல, நான் கிளாஸ் உட்காந்துருக்கேன், கிளாஸ் பார்த்துட்டு போ அப்படின்னு சொல்லிட்டீங்களா? ஆ ஆ ஓகே 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 சரி சரி எப்போ போறீங்க சார்? எத்தனை மணிக்கு போவீங்க? அப்படியா? நாளைக்கு நாளைக்கு எனக்கு 10 கிளாஸ் 9:30 10:30. அப்புறம் இந்த பசங்க கிளாஸ் வந்து 11:30 12:30. அதுக்கப்புறம் தான் நான் வேணா வருவேன். கேட்டு பாருங்க. சரி அப்ப நீங்க போயிட்டு வாங்க, ஒன்றும் பிரச்சனை இல்லை. பார்க்கலாம் பார்க்கலாம், நீங்க பண்ணுங்க. இப்போ இன்னைக்கு முடிச்சுட்டு வரேன் நான். சரி சரி ஓகே. ஆமாம் ஆமாம் சரி சரி பார்ப்போம், நாளைக்கு பார்ப்போம். ஓகே ஓகே சரி பார்க்குறேன், நாளைக்கு நான் கேட்டு பார்க்குறேன். ஓகே ஓகே. இல்லை இல்லை யூஜி பண்ணணும் இந்த பசங்க கிளாஸ். என்னைக்கு? இல்லையே சார், எனக்கு அடுத்தடுத்த தவறு வரும் சார் எனக்கு கிளாஸ். நான் பார்க்குறேன், நான் இந்த முடிச்சுட்டு வரேன், கொஞ்சம் இந்த பேசிட்டு வரேன், இதை முடிச்சுட்டு வரேன், கிளாஸ் முடிச்சுட்டு. So I'm not confusing you with more of formula. So what is that you should remember is L is equal to D is equal to Ks plus C if it is perfectly horizontal. You agree? Okay?
Yes, sir.
Yes. If the angle of if the line of collimation is inclined to the horizontal angle by theta, then the formula takes the shape that L is equal D is equal to Ks into cos square theta. The cos of one angle and the second cos. So cos square theta plus C cos theta. Okay. So once you find out what is that horizontal distance, the vertical elevation is h. Vertical elevation is h. H is given by d tan theta. Is it okay? Right. Then you have to apply your principle of your mathematics and then find out what is the elevation difference in the horizontal distance. But here I just wanted to tell you there are two constants. You know what are those two constants? Multiplying constant and the multiplying constant and the multiplying constant equal to K, additive constant is equal to C. The K is normally 100, C is 0.10. So what they have done is they have introduced what is called an analytic lens, and then made this C as 0. So one more addition here it been made so that the C becomes 0 and the K is equal to 100. So most of our modern instrument, it is nothing, your D is equal to Ks, and if you got an inclination, D is equal to Ks cos square theta. Do you understand that? Okay. Shall we frame a problem and work out? Suppose the staff intercept is 1, 2, and 1.5. The axial hair reading, bottom hair is 1, middle hair is 1.5, top hair is 2. If theta is equal to 30 degree, theta is degree vertical. Line of collimation. So you have got RL of line of collimation. RL of LC is 100.5. Okay. Find out. So you have set an instrument at A, and I have got top at B. The top is held vertical. The vertical angle is theta 30 degree. Okay. And I have read the staff intercept as 1.5 and 2, and the K value is 100, C value is 0. Find out horizontal distance and the RL of point B. Can you work out now? So what is S here? What is S here?
1, sir.
1. So 1 into 100 into cos square 30. How much is that? One into 100.
75.
Huh?
75.
Huh? Cos square 30.
$75, sir.
Cos square 30, 75 meters. D is equal to 75 meters. You get the same
Yes, sir.
answer.
Sorry.
Huh? Point 75 meter. Okay, fine. Now what is H? What is H?
$43 meters, sir.
43.3. 43.301. No? H is equal to. So what is RL of B? $100.50. Tell me,
57.199, sir.
how do you get it?
100.50 minus 43.
Minus 43.301. Ah.
57.1.
But what happened to that 1.5? So data insufficiency is there. Isn't it? Data insufficiency is there. RL of line of collimation I have given it. So 100 This is 100.500. Over and above this is 43.301. So you take 100.53 plus 43.301. So 801, 143.801 is this, minus of 1.5. So 103, 142. So the RL of this point is 142.301. You get the point? Right? So you have got RL of this plus height, the center of that, minus of 1.5, you get the this thing. RL, this level line and this point does not coincide. You get that? So this is what is called as the tachometry. Tomorrow you have a third hour class, no? Can you postpone it? Can I have it by 4 o'clock in the evening? Decide and tell me.